Good afternoon and welcome everyone to Scientix STEM Alliance Future Classroom Lab and Clarios webinar, Powering the STEM Future, Silk Road Economy in the Classroom. This webinar tonight is co-organized by Scientix, Future Classroom Lab and Clarios. My name is Isidora Salim and I work at European SchoolNet as a pedagogical and project coordinator, and I have the pleasure to be your host today. So first thing first, let's go through some housekeeping today. As you know, the webinar is recorded and your cameras and mics are disabled. So for all and any questions to engage with the speakers, please use the chat box. In addition, we will be sharing some valuable information and helpful links through the chat box during the webinar, so keep an eye on it. And last but not least, don't forget to sign the signatures correctly in the participants list and get there. Today in this session, we will have the pleasure to also hear some experts from Clarios.
Hello, good afternoon, everybody. My name is Christian Rosenkranz. I'm responsible as a managing director for Clarios Germany. I hope you can hear me clearly since we're experiencing some technical difficulties. If my sound is interrupted, please let me know. Otherwise, I would like in the next 10 minutes to make you familiar with Clarios and why we support the Scientix initiative in STEM. It's subject to our heart since we deal with a very technical product, a battery, which has an essential role for a lot of vehicles in order to gain higher efficiency. As you can see from Clarios, our mission profile is to create the world's best batteries essential for the evolving future of transportation. We are experiencing a lot of changes in vehicles to higher efficiency powertrains, not only by the pure electrification, but also some other features which I'm going to make you familiar before we are passing it on to my colleagues Ulrich, Irina, and also Lali to bring us more details on how that translates from our product and the future skill sets that we need into our social activities and STEM activities at Clarios. Without further ado, why are we doing it? Clarios engages in three triple bottom line topics. We are doing it, our business, creating the world's best batteries, first and foremost for a suitable and sustainable business, of course, because we have some strategic products and are on a growth trajectory. But also, all that we do has an element of sustainability. You will see later on that we can reduce our carbon footprint by using new technologies like sodium-ion compared to lithium iron phosphate and other technologies. But also, we have a high circular economy aspect. Batteries that we produce today have one of the highest degrees of circularity and recycled content used in new products that you will find amongst the major commodities. And of course, we protect our employees and protect also the environment and our customers by extremely high safety standards. So what are the products we're talking about? A quick introduction into Clarios. We are a hidden champion. We are number one in the global market position. We supply in over 100 countries our customers. We have a mixture between supplying directly car makers as well as replacement batteries for the aftermarket, as we call it, which gives us always access to the latest technology and demands of future powertrains of our vehicle manufacturer customers, but also securing a business supplying batteries then during the entire life cycle of the car. If you take one number away from this chart, then please the number which is shown on the upper side of the slide, the second to the right. 1 in 3 vehicles has a battery from Clarios, which means that we are really widespread with 155 million batteries provided annually in all vehicles on the planet. The 3 major trends we would like you to make you familiar with are electrification, digitalization, and circularity of future powertrains. Electrification is not only electric powertrains. It basically means that all devices in a vehicle, which used to be in the past to be hydraulically articulated and operated, braking systems, steering systems, are now X-by-wire, drive-by-wire components, which are decoupled from any mechanical impact and propelled with a very secure battery system with redundant backup power in order to have fail-safe routines similar to an aircraft, having 2 redundant power nets in order to have always in all situations the full control of the safety critical functions like braking, steering, and others. It's going to be even more paramount in the future when we have more and more autonomous drive functions embedded into the vehicle, which means that you need to rely on the electrified components more and more, have high predictive maintenance, but also predictability of the functions and the power capability, and hence our products at Clarios get more and more sophisticated, talking to the powertrain, always giving their state of charge and function so that they can rely from the vehicle control unit on the functionality of our batteries. And also, since we have more and more electrified components, voltage stability becomes more and more important to the vehicle. And the stability means that there shouldn't be any critical voltage levels bypassed, which means very high prediction also on aging phenomena of the battery in order to have a very stable supply over life. Digitalization is very interesting. It's not only the ongoing human-machine interface scenarios and larger displays we see in the vehicle. It's more and more sensors, probes for the autonomous driving that need to send images, surroundings of the vehicle, in order to have artificial intelligence analyze data on scenarios during the driving so that the ADAS function, autonomous drive assist functionalities of level 3 and above can be propelled. Last but not least, circularity. It's reducing constantly the footprint, the carbon footprint of our batteries by using recycled content, but also by more and more functionalities that we propel with green electricity in the manufacturing of our products. And last but not least, it is also the use of recycled content in new vehicles, which becomes very important to our customers in order to demonstrate that the overall carbon footprint of the vehicle and the recycled content use is increased. That's an eye chart for everybody who is not that technical, but let me quickly summarize what is shown on the slide. We do have on the left side the classical functions that we have with propulsion, sustainability requirements, but we see also more and more functions to the right side, like software, battery management, packaging, high power features, load stabilization. Batteries that we provide to the industry, like 12-volt systems, are also providing kind of a balancing function to power nets, buffering and peak shaving of high power consumers that quickly demand power and supply in the powertrain. And all these functions add more and more complexity to our business. Hence, more skill sets are needed in the next generation. Also, all the apprentices we have in our plants are very rarely only being educated in mechanical structures, but also in electrical systems, operating more complex machinery and equipment in the manufacturing process, but also programming the software needed in order to have the right battery management system data. So it becomes more an integrated package of skills needed for the future of designing our products and being able to deliver the next generation of batteries for low voltage powertrains. Last but not least, I would leave you with this slide, which shows the recycling aspects of our business. As of today, we are recycling every hour over 8,000 batteries in our global network, every hour, 24/7, every day. We have a very high vertical integration in Europe, being able to supply ourselves with 40% of our lead on recycled content or recycling basis. We collect nearly 100% of our batteries, and every battery we supply can be recycled. So 100% of the products sold are recyclable. There are losses for all with scientific background amongst the audience, of course, in the process. But what is beautiful is every new battery that we produce has already 75% recycled content in metal components and over 50% recycled content in plastic components, which is unique in the industry. You can see on the bottom of the chart the certifications that we got. We have the third year in a row the Most Ethical Company Award from Ethisphere, tricky for German tongues. We are rated by Sustainalytics. We have won last year the World Sustainability Award for recycling practices. We have a preliminary Morgan Stanley rating on sustainability and ESG. Why preliminary? Because we are still not a publicly listed company. And we have an EcoVadis rating being on the top 25 percentile of all industry peers when it comes to our sustainability parameters, which is not only recycled content, but also the other two elements, social and governance. So with that, I wanted to give you a quick overview, and I'm going to pass it on again to Isidora.
Very much, Christian. Thank you for presenting and how the changes in battery technologies and how your company is impacting the sustainability of it and how it's taking care of the environment throughout the work. So for all the questions you have for Christian, please feel free to leave them in the chat and we will address them during the Q&A. Now let me give the floor to Ulrich Germ. He's a manager for training and technical support at Clarios, and his team helps partners and customers across Europe to grasp the importance of energy storage in modern vehicles. And throughout his presentation, he will show us how educators can use batteries to teach STEM in a contextual way to empower the students in the classroom. So Ulrich, the floor is yours.
Okay, so yes, thank you very much. And I will represent here now the Vata brand, which is in Europe the strongest battery brand we have in Clarios here. And what we're doing here in our training academy is actually educating the workshops. As Christian mentioned, I mean, our engineering is at the very forefront of the vehicles nowadays being developed by the car manufacturers. But nevertheless, a lot of our business and our products we sell into the independent aftermarket. That means we also need to educate those people working there for the vehicles which are maybe at the moment in the actual use in the car park, and actually they are complex anyway. Even though if they don't have this autonomous driving so much, and also we don't see so many hybrid vehicles, for example, in the aftermarket. There have been a lot of changes in the past where we need to educate the workshops to do the proper battery replacement. And we started this training academy activity already a couple of years ago. And what is important is that the training is not only about the battery replacement, but also on effective problem solving around the vehicle, because especially in aged cars, if you have any issues with the batteries, that is maybe only a symptom, but the root cause is somewhere different in the vehicle. So this is what we're doing. And what you see here in the last bullet point, and this is something I think very important and very exciting for, especially when we're talking to young students, is that we go more and more into virtual training environments. So we currently launched a tablet app. I will show you later on, but also we are now working on something like this here with virtual glass from the Meta Quest. So this is where we're going to do the trainings more interactive and even more engaging for the younger students. So to make it short here, I think the most important thing here is that actually no vehicle out there will start with a flat 12-volt battery. Even full electric vehicles will not, you will not even be able to unlock the car if the 12-volt battery is flat. So it is a very essential part, but it will also remain a very essential part. And this is why it's so important that we educate the workshops and the people working there. This is just a quick overview here. You don't need to go through the slides here. We have a training for 2-3 hours to go through them in detail. What I would like you to take away is that we have a couple of different technologies at the moment in the 12-volt battery starter or a starter battery environment, but from the outside, they're looking pretty much the same. Nevertheless, they have different performances and different performance capabilities. And what we usually also then use in our training materials when we do the battery trainings is to having the comparison here that we compare. On the right-hand side, you can see the standard or the lower class vehicle with a standard battery where the battery is not as much used as, on the other hand, if you take a look into the premium car, you see a lot of more fluctuation, and this is the insight why the battery is being treated differently and why why a different technology and more powerful technology is being needed in those vehicles. This is what it looks inside, and this is what we print into books and into materials. But as I mentioned, we have what we call the Battery Explorer. So this is an augmented reality app, and I will keep the QR codes here for the Google Play Store and for the App Store for a moment here, but also on the other slide. And what you can do here is you can put the actual battery or the virtual battery into the actual classroom environment, for example, can disassemble the battery down to the component level and view that one from all different angles. And you also have then explanations when you want to look into certain components here. And this is what we also do a lot for trainings. And you can do some nice challenge out of it, or a more interactive part that people or the different groups of students discover different technologies and then report out what they found out here. No worries, the QR code will be there on the last slide as well. Because what I would like to use the second part of my short presentation here is also giving some ideas why the battery is a perfect starting point for electrical training. And the first thing that came in my mind is it's a nice application of the Ohm's law, because every battery has an internal resistance inside, and that you have these links from the Ohm's law that the higher the current you want to drain and the higher the internal resistance you want to drain, the lower is the voltage you can measure on the terminals, because the higher is the voltage drop on the internal resistance. So you can use that example already, and this is something you can actually measure on the battery to give a practical examples of the impact of the Ohm's law. We can also use the battery to educate about series and parallel circuits inside of the battery, because the battery itself is made out of 6 individual cells. Each cell has a voltage of around 12 volts, and if you put them in series connection, you sum up the total voltage that you end up with a 12 volt we see on the battery terminals. But we also have a parallel connection inside of the battery, which means the more current you would like, or you need out to to get out of the battery, the more plates you need to have inside of the battery. And those plates are being connected in parallel. And this is also the explanation why the battery, the bigger it gets, the more current it can provide to the alternator, to the starter motor. And taking also not only the look inside of the battery, but also into the applications. I mean, here in Europe, all the trucks are being equipped with the 24-volt systems, but powered with 12-volt batteries or equipped with 12-volt batteries. So the question is how those batteries needs to be connected to supply the sufficient voltage to the truck. And in the USA, the situation is even a little bit more complicated because they're using smaller batteries. And that means they need to connect more batteries to each other to achieve the necessary starting current. Here the question is, okay, how do I need to connect my 4, 6, 8 batteries to achieve the right voltage level and the right starting power? And another good example here is, for example, the capacity. What actually does the capacity and the dimension amp hours mean actually? So you can split it up into amps and hours, but you can also put that into context, saying, hey, these are for example, some consumers I have inside of the vehicle. What does that mean if I have a 70 amp hour battery capacity, but a current consumption of 35 amps, just from a few consumers? How long will the battery last until it's totally flat? And I think these are just some examples how the battery can be used for basic electrical trainings. And hope maybe that inspires you to use that for your own education. And again, here are the QR codes for the Play Store and for the App Store. And have fun with the app. It's really exciting. I mean, on the one hand, it's interesting to have an inside of the battery, but it's also cool having this augmented reality experience. And from the feedback I got so far from our customers, but also from other schools and teachers, they really like that, and it gives another level of excitement into for the education. And with that, I will already hand over to my colleague who guides you through the next topic.
Thank you very much, Ulrich, for providing the interesting resources and ideas for how to present batteries in the classroom. And more on that topic, actually, and even further in how to discuss about batteries and sustainable circular economy and sustainable collection and recycling of batteries. We will have our pilot teacher speaking. So first, to present her work on the learning scenario, Mission Voltra is our scientist pilot teacher from Greece, Georgia Laskaris. Georgia is a computer science teacher and a software engineer, worked both in primary and secondary education, and Georgia prepared and piloted the learning scenario in primary school. So I let her tell you more about it. So Georgia, the floor is.
Thank you, Isidora. Thank you very much for this opportunity, such as Clarios. So my name is Georgia. I'm a computer science teacher, and today I will present you the implementation of the learning scenario Mission Voltra, from battery secrets to sustainable solutions. The learning scenario is an inquiry-based learning scenario where students act as agent of energy. So through playful activities, hands-on experiments, inquiry-based activities, role-based investigation, the student explore the world of battery, how battery work, their environmental impact, and the need for sustainable solutions. The learning scenario promotes critical thinking, collaboration, real-world problem solving, STEM careers, and the contribution of women in science. It involves some STEM subjects such as science, technology, ICT, computer science, engineering, arts, mathematics, and not STEM ones such as environmental studies and social studies and ethics. The implementation took part in 2 schools, the second and the third primary schools of Eritrea in Athens, involving 3 classes of 10 years old students within the subject of skill labs, computer science, and natural science. The learning scenario was designed as a spiral, so students started with very simple ideas, and then step by step they build new knowledge. So we started with the kickoff activity and escape room. Then they learn the basic functionality of batteries and some of the environment issues that may occur. Then they create their own batteries. In the third activity, Big Batteries, Big Questions, they learn about the real-world problems that are related to the production and the use of batteries, and they had to investigate and propose solutions. Then the 2 last activities, the battery awareness campaign, they use all their knowledge to create a campaign about the responsible use of batteries and women in science. The last one connects the classroom to the industries and the STEM careers. For example, if it's an optional activity, of course, if we can invite an expert to school to really explain us batteries as we heard today. Because the students, my students were younger than the one that the learning scenario was addressed, I decided to gather all the materials of the learning scenario, the materials for the teacher and the materials for the students, into one place. I used to create a blog using the educational free platform IMI4All, which provide me not only the web pages to share my content with my students, but also to create content and make assignments and create the questionnaires, quizzes, etc. So the first activity was an escape room. The students entered the escape room and they had to discover different types of batteries and how those batteries powered different types of devices, from simple one and more complicated one, like the car's batteries, which is not a subject that students really know about. It was a very quick activity. You can see the students working in teams. And they also learn about Alessandro Volta and the role of, and why women back then had fewer opportunity to learn about science. The second activity was also a mystery one. So in the Volta laboratory of the escape room, they had to, they found some top secret videos and top secret documents explaining them how battery works. So they had to really watch the video, read the resources, the top secret documents, and then complete 3 missions: the Energia one, the Green Volta, and the Red Toxel. Because my students were quite young, I decided to create this activity not to use the worksheet of the learning scenario, but to create an interactive quiz with the technique, drag the word technique, so it was more engaging and interactive for young students. And it made me gain a little of time, because, you know, at school we always have this issue with time. So once again, working in teams, they went through the resources, they complete their mission, and they presented their mission in plenary. The second activity was, now that they know what it is inside a battery, to create their own battery. Once again, all the learning materials of the learning scenario were gathered in one place, in one page, and the students had the opportunity to see all the videos. We started with the first videos where we programmed our microbits, our BBC microbits, to record the voltage of some batteries. Then I created for each class 4 workstation, one for a lemon battery, one for a vinegar battery, one for salt water battery, and one for potato battery. So students had all the materials ready to start their experiments. Step by step, they build their batteries and they measure using their microbits. They measure the voltage of the batteries, but as we see, the voltage were not enough to power on the LEDs we had in the laboratory. So we follow the instruction of the video tutorials, and we connected the batteries in series. So, for example, here the lemon battery and the potato battery produce about 2.9 volts. So we could light up the red LED, and then we had different experiments. And finally, when we put in series all the batteries, we had 3-volt battery, and we could very easily light up the other LEDs, the yellow one and the blue one. Now, the next battery, the students act as experts. They had to investigate some materials, some videos, understand the issues, the problems, the solutions proposed, propose themselves some solutions, and then participate in the Voltra Council meeting and explain the problem, the solution, and what they could do in the future. So they had each team. We split the class into 3 different teams. They have the environmental scientists, the car and battery engineers, and the recycling experts. So each one had to investigate the given videos and try to understand what was the problem, the solution, and propose their own solution in the council. So first, in teams, once again, they watch all the videos at their own pace, and they had the opportunity, of course, to customize them, customize the speed, the caption size, the translation, of course, because the language is a barrier. And they very quickly, they put their ideas and what they learned on the worksheet. And then we had the Voltra Council meeting where they were engaged in discussion and explained each one their point of view regarding the production, the use, and the recycling of batteries. The next activity is the campaign awareness activity. It's still an ongoing activity. It's not finished. Once again, in their teams of expertise, the students had to design some poster about women in science, but of course about the responsible use of batteries. So here you can see the car and battery engineers explaining why we need some innovation in new batteries and why the new cars are more demanding of new technology for the batteries. And I think that we will finish this activity next week. So the impact on students, they were very engaged. They love to work in team, to move around the classroom, to find all this, to do the investigations. They had some difficulties, of course, because they are not used to work this way, to find the clues and to find the answers. But they really understand because we were repeating one again and again the main concept. At the end, they gained a very good understanding on how battery work, their role in the green energy transition, and also the the importance of recycling and of a circular economy. So some takeaway for the implementation. Of course, it's not a secret. Preparation. You have to prepare your materials. You have to have them in hand. You have to go through the experiments and see what materials you will need and what materials are adapted to your classroom. And of course, I think that it's a very good idea if you can find some 2 or 3 consecutive hours to run the activities, because it's more easy for students to follow. What's next? So taking it to all those activities, we will take part to the European Code Week to the European Code Week with the microbit activity. We will take part to the European Week of Waste Reduction, to the COP13 in Brazil, and to the International Day of Women and Girls in Science. So that was all. I hope you enjoy it. So Isidora.
Thank you very much, Georgia, for presenting the learning scenario in such depth and for presenting how the implementation and the piloting go with your students. As far as I can see, it has been a valuable experience for both you and your students. So, guys, if you have any questions more for Georgia, feel free to share them in the chat and I will address them during the Q&A. And now I will take a few moments of your time as well to present the second learning scenario that has been developed by our second pilot teacher. The learning scenario is for secondary schools, and it has been developed by Olivera Stojakovic in collaboration with UN staff. As I said, the learning scenario is called from STEM to learning, from STEM learning to sustainable action, and it is intended for secondary school students, specifically for students between 13 and 16 years old. It is a very interdisciplinary learning scenario that can be implemented in subjects such as chemistry, environmental science, ICT, but also civic education, road and vehicles can be implemented both in vocational schools and gymnasium, more general lessons. So the learning scenario is actually intended to be implemented through 2 lessons, and students explore how lead batteries work and which are the main type of car batteries, as well as how this production and recycling of car batteries can implement further the economy and contribute to transit to circular economy on a global scale. Through practical tasks such as online research, data compiling, and analysis through spreadsheet work. So through different online tools, digital tools, students were able to conduct research on different types of batteries, how they can be used, how can be implemented and used in daily life, which are the correct ones for correct cars, what needs to be considered to properly maintain the batteries, and so on. This all data was compiled into spreadsheets. Students worked on analysis of this data, and they worked on creating a more elaborate approach in their schools, how they can help with the proper recycling of batteries and what they can do on the ground right away within their scope, within their world, to contribute to raising awareness on proper maintenance recycling of batteries. The learning scenario, as in Georgia's case, was piloted with 14 to 15-year-old students and in collaboration with the ICT teachers. These students were actually a part of the vocational school that Olivera is working in, and this is a road transport and technician program, and the subject of implementation was road vehicles subjects. From Olivera's report, students were very engaged and very enthusiastic about the activities because they were not only theoretical, they had within the implementation process, they had the chance to watch very engaging, very short and clear videos to understand the functionalities of batteries, what needs to be considered, and they had the chance to combine this theoretical knowledge with practical works, with using different digital tools, with using battery finder, Excel spreadsheets, Canva, and different online tools to create this final product for them, which was the awareness raising campaigns that they ran within their schools. They also indicated that they really enjoying combining that work. They really like that this was connected through different lessons, that it wasn't just road vehicle subject, but the ICT teacher was involved throughout the whole process, and that they really enjoyed that they had the chance to really take action and show their peers what can be done even on a small level, such as their classroom or school. This is from our pilot teachers, but don't worry, materials will be published on Scientix repository. So both Georgia's and Olivera's learning scenarios will be available there in the following weeks. And the materials will be promoted through Scientix social media channels. So stay in tune, check the Scientix repository, check social media. And you will be able to find the new resources there. To continue with the agenda now, I would also like to invite and introduce Irina Kudenko. She's the Corporate and Social Responsibility Lead for the EMEA region at Clarios, and that her team believes in building community engagement and impactful partnership that can help champion STEM education and sustainability. Through the presentation, you will discover how to use real-life cases like Clarios idleness solution to bring sustainability and green products into your classroom. So, Irina, the floor is yours. You can take the floor.
Thank you, Isidora. And so thank you for the slides. So let's go to the start. So I'm delighted to be here to present you. So we've just heard excellent lesson plans and also reports about the implementation in 2 schools, but I'm delighted to present you another real case story from Clarios, which we are sure will be an excellent addition to your learning resources in teaching various STEM subjects. So let me first start with introducing the concept of idling. I'm sure all of you are familiar with the situation when the engine is running, but the car is not. So the car stopped, but the engine is on. And all of us face it, but it's particularly aggravating when in big parking lots where you see a lot of trucks staying overnight or just on a long rest, and their engines are on in order to charge batteries so that they can enjoy the use of microwaves, air conditioner, and all other hospitality features. And this, of course, leads to wasted fuel, unnecessary costs, increased emissions, and battery wear. So there is always a question, how can we cut it down? And Clarios offers one of the solutions, which is called idleness solution. And this is a real thing. It's part of our Clarios Connected Service offer. And you can read more about it on our public website. There is also here a link to the case story. But basically, what is that solution? And you can see on this picture various parts of that solution. It's a smart battery monitoring system, and the cool part is that it actually uses cutting-edge technology, sensors, AI algorithms, and real-time alerts to help drivers optimize vehicle operation and ultimately cut unnecessary engine idling by up to 60%. And why it matters is because it actually does lead to incredible fuel savings, cost savings, what is more important, CO2 emissions reductions, reductions in wear and tear of the engine, but also of the battery. And that also gives a peace of mind to drivers so that they can enjoy their cabin comfort without guesswork. So how much battery do they still have and whether they need to switch on the engine. In terms of relevance to STEM education, we believe this is an excellent example how technology and data tackle environmental problems. And it teaches students that creative design can actually can be used to cut fuel use and emissions. And because it's a real life case study, it actually combines various, it tackles to various STEM disciplines, and it's doing it in a hands-on and engaging and motivating way. And just to illustrate for you how, so we have kind of put together some ideas of how this case story can be used to enhance your teaching in various STEM disciplines. So for instance, in science and technology, and that is applicable both to primary and secondary schools, it can be used to just simulating idling by using a battery-operated toy car, just flip it on the roof, and to demonstrate and to simulate idling. It's quite powerful, and then you can actually use it and train data analytical skills of your children, of your students, by comparing idling and idless scenarios. And continuing with the math, for instance, this is a nice way of sort of math problem solving, so where you can calculate impact for a fleet of vehicles. So how much fuel and CO2 emissions can be saved, and you can make it more complex by actually putting specifications for different vehicles or different types of use. And of course, this is also, you accumulate lots of data, which can be used for visualization and sort of training graphing skills of the children. Quite straightforward is the application to geography, environmental studies, maybe other social studies, maybe business studies as well, where you can sort of have discussions about whether it's a local relevance and whether, so how idling, reduction of idling improves air quality in the particular locations. Or it can be a policy debate, just discussing with students, engaging students in a discussion of when such technologies exist, what should we do in terms of encouraging or maybe mandating the use of certain vehicles in certain places of this technology. And then last but not least, and maybe most evident, is the use of this case story would be for teaching green design. So we say here as part of engineering and design. So here it shows sort of a secondary school, but actually with some modifications, it can be perfectly adjusted for teaching green design in primary school as well. And by green design, we mean engineering products or processes with environmental sustainability as a core goal. So, and this can be, of course, combined with various activities like, for instance, inviting students to research and discuss everyday examples of green design. Or it can be a problem-solving challenge of taking a common product, which is not done with sustainability in mind, and maybe asking or inviting children to solve this challenge and to see how this can be redesigned in order to make it more sustainable. This can become a student project or even lead to a big showcase where you students present their prototypes or posters or suggestions on different products and different versions. So on this cheerful note, I am finishing my presentation and inviting you to comment on, put questions, and maybe also comment on how you could see using this in your class with your year groups. Thank you.
Thank you very much, Irina. We are running a bit of tight in time, but nonetheless, we still have time for Dr. Lali Bilaya, the human resource lead from Clarios, Spain, and during her presentation, she will highlight the evolving industry careers and the advancement of women in STEM. So, Lali, the floor is yours.
Yes, thank you, Isidore. Good morning, good afternoon, everybody. So I'm really sincerely glad to be here today as a part of this exciting conversation about empowering the STEM future. We just seen how batteries can spark curiosity of our students, and I would like to explore in a little bit in different dimension how sustainability is shaping STEM careers. So if we go to our classroom and to ask our students, especially as girls, can clearly see them at STEM career in the future, if they would like to be and to know such position like a battery recycler, green chemist or data scientist or for sustainability, probably not many. It's really related to the position and to changes what we can observe on the labor market. If, for example, 10, 15 years ago, we had the major bulk of position like operator, drafting specialist, some draftsmen, etc. So just right now, it's converted to digital twin modeler, artificial intelligence system engineers, etc., etc. So, and we are not sure that in the next decade, in 10 years, we will continue to have the same job positions. And there are careers that today's students could step into the next decades for today. And this list of new created position requires new skills. What we can observe on the labor market as well, what we face as HR. I'm working in the HR department, and I faced with this on a daily basis that these roles combine STEM knowledge with soft skills that teachers already nurture in their classroom. You can see here that concurrently with the math and computer science, robotics, problem solving, equally important design, how we make a presentation, how we can debate, how we can work as a team players within one group. And it's really great to understand that these roles equally developed our students to grow them within STEM career. Georgia before mentioned that in their class they discussing as well some role of women in science, and we also as a Clarios we really pay attention on this topic. If you can see on some statistic data for the last 13 years, for example, only for one country in Great Britain, number of women working in engineering roles has increased by 8%. So we are continue to observing how our women are growing for leaders positions, but they're seeing more women step into the leadership roles as well in renewable energy, clean tech, startups, better technology, etc. And Clarios as well decided to support this global tendency. And we have created 2 years ago the global program called Business and P&L Exploratory Program, P&L Profit and Loss. In the USA have been selected 9 greatest high potential women, and during their second year after their job shadowing process, 4 of them been proposed for their higher level promotions. And all of them are equally developed during these 2 years, leadership skills as well as business acumen or financial skills. It's really important for both sides, for the future leader and for the company. Also, we are concurrently collaborating with ASTI Foundation in Spain, especially, and you know that its mission of ASTI is to promote STEM vocations, science, technology, engineering, mathematics among the young people, especially girls, to help them to meet the growing demand for STEM profiles and reduce the gender gaps. These soft skills and STEM skills actually could be very valued for us to grow our students, to show them how they can be successful in a STEM roles and STEM career with sustainability. But it's not enough. There is a lot of gap actually. Women remain underrepresented in engineering, technology, and senior decision-making roles. So how we can be helpful with that. In our classrooms, additionally to some escape rooms and some activities what Georgia and Irina already offered, we can also invite some successful women leaders from the market who can share their successful story. We can arrange some mentoring program or shadowing process with the other universities or with some companies. We can show and invite our students to visit to our plants, to our fabrics, to see and to touch exactly the product, our batteries, how it looks like from the beginning and what we will receive at the end of the process. So it's really magic process, and everybody who visited us really at the end of our plant tour are very excited and very motivated to grow within this industry. So at the end of my speech, I would like to emphasize that sustainability is not only about protecting the planet, as everybody understands that. It's about the creating meaningful, future-proof changes. So just let's help our next generation and students realize when they choose STEM, they are not just choosing a subject. They are choosing possibilities to shape more sustainable and more inclusive future to all. And also, we can inspire girls and boys alike to see themselves as a problem solvers, innovators, and real leaders to change. Thank you. And that's it from my side. If you have any questions, please welcome. You're very welcome to ask. Thank you. Isidora, hand over to you. Thank you.
Thank you very much, Lali. Thank you for actually addressing a few of the questions already throughout your presentation. I would just like to just tell you a bit of for the upcoming STEM Discovery campaign. So everything you heard here today, all the new materials that are coming up, that are coming on Scientix repository, try them out in your lessons and prepare already your entries for the new STEM Discovery campaign. As every year, it will take place between the 1st of February and 30th of April, where you can tell us everything that you did in the past year when it comes to STEM Discovery campaign, and check and maybe win an opportunity to come to Brussels and attend the SPW and so on. With this little time left, I would like to address maybe one question, and that is what opportunities, in addition to what we provided already, can you give some your final thoughts, all of our speakers, just 30-second final thoughts of how we think that batteries fit into the classroom activities, and what would be the best way, in your opinion, to introduce them to which lessons and activities. So please, you can speak as you prefer.
Oh, let me kick us off. I think, sir, we have been talking about it for the whole hour, but maybe just the key elements. I think we talked about the trends, and that sort of connects to various STEM subjects in itself. So Ulrich what we presented, this more traditional and more obvious connection with the electricity. But I think what we also wanted to show is the connection to sustainability and circularity, which is quite important, which is not visible to the majority of people. Our product is not very visible, but quite essential. But it's also the circularity and sustainability aspect that makes us all very excited, and also looking for diverse workforce. Yeah. So we also see a special place for women there. It's kind of that's my summary for the whole hour, but I'm passing on Christian. Maybe you want to add.
In the interest of time, I would pass it on, I guess, to my colleagues or to Georgia.
I think, like Irina said, the first is every environmental program can host the battery theme. everyone, from recycling from circular economy, from everything. And of course, there is all the subjects of physics, of natural science, electricity, the voltage, everything. So it's not so difficult to incorporate this theme in the curriculum.
Amazing. Thank you very much, Irina and Georgia, for the final words and the summary and the final thoughts. With this, I would like to thank all of our speakers for joining us today, for sharing valuable information with us and valuable practices, and to invite all of our listeners, well, our attendees, to fill in the signature list if they haven't so far. Follow Scientix social media and Scientix repository for the new materials that will come in the following weeks. Thank you very much and have a pleasant evening.
Thank
Thank
you.
you. Bye.
Thank you.
Bye
Bye-bye.
bye.